Hello and welcome to the Alternate Physics. Today I'm going to show you a piece of code that actually a very simple piece of code that does not work for a particular input. Okay, let's go to the code. So here is the code that I have written. I have written a function called reverse integer that takes an input and stores in a variable called x. Then I finds the negative of x and stores in a variable called y. And finally I print the value of this y, right? Okay, let's run this code. So it is asking for a number 6. Negative inverse of 6 is minus 6. Okay, minus 10. Negative inverse of minus 10 is 10. Okay, so far so good. Now I'm going to show you a particular piece of number. This is the number that I'm talking about. If I input this number and I hit enter, what the hell? It says the negative inverse of this minus this negative number is this number itself. What is going wrong? Okay, let's do one thing. I will decrement this number from 48 to 47. Now it works fine. What is really going on? What is the problem with this number, this particular number? Let's find out. Okay, so when we say integer or int, it really means that 32-bit signed integer. Now, 32-bit signed integers are stored in computer in a form called 2's complement. What does it really mean? Now, 32-bit means there's a location of 4-byte memory, right? And each bit has its own positional value. For example, this guy 0 here, it has a positional value of 2 to the power 0, which is 1. Then the next guy has a positional value of 2 to the power 1, which is 2. And it goes on like this until the last point, this guy. So this last bit, its positional value is actually minus 2 to the power 31 and not plus 2 to the power 31. So all the bits from 0 to 30, they have a positional value which is positive. And the last guy has a positional value negative. So this is how computer stores negative numbers as well as positive numbers in 2's complement form. So if the last guy is 1, then this number is negative. And if this last guy is 0, then it means the overall number is positive. Now, it may be a bit difficult for you to understand what's really going on in this 32-bit form. I'm going to simplify this and I'm going to explain you everything in 4-bit signed integer. It's a hypothetical situation. Let's jump in. So here I have written down all the different bit patterns that can happen in a 4-bit signed integer. Okay, 4-bit signed integer. Now in a 4-bit signed integer, there are 4 bits, and let's see what is the positional value of each bit. The first bit has a positional value of 2 to the power 0 or 1. Second one will have a 2 to the power 1 or 2. 2 square or 4, and the last one, it will have a positional value of minus 2 cube or minus 8. Okay, so this will be okay. Now let's jump to this guy. So these are all the bit patterns that can happen in a 4-bit signed integer. So we are starting with this guy 1000. What is the value of this guy? Its value will be minus 8. This guy will become minus 8 plus 0 plus 0 plus 0. So it's minus 8 overall. This guy will be minus 7. Why? Because this bit value, the value of this bit is minus 8. This guy is plus 1. So minus 8 plus 1 is equal to minus 7. So this is how we are going to move forward. Minus 6, minus 5, minus 4, minus 3, minus 2, and finally minus 1. So these are all the negative numbers that can happen in a 4-bit signed integer. Then we come to a stage where all the bits are 0, its overall value is 0, and the positive ones are just as usual. 1, 2, 3, 4, 5, 6, and 7. So these are all the different numbers from plus 7 to minus 8. These are all the numbers that can be represented in a 4-byte signed integer. Okay, so how does computer really finds the negative of any number? Like what really goes inside that arithmetic and logic unit. I'm going to show you in now. Okay. So let's say we have a number, I call it x, okay? Let's say its value is like anything like 0, 1, 0, 1, okay? Let's flip all the bits of x. I'll call it x bar. So what is the value of x bar? It will be 1, 0, 1, 0, isn't it? We are flipping all the bits of x. Now, if we add them up, what do we get? It's clear. You take any number, you flip all the bits and you add them. You will always end up with 1, 1, 1, 1, right? And what is the value of 1, 1, 1? We notice that the value of this 4 ones is -1. Okay? So this equation is always true. X plus x bar is -1. We can rearrange this equation in some way. For example, x bar plus 1 is equal to -x. And finally, we get that -x is equal to x bar plus 1. This is the strategy that computer follows to find the negative of any number. So first step is you flip all the bits of that number. Flip all the bits. Step 2, add 1. For example, let's look at this previous example. We started from 0, 1, 0, 1. We flip all the bits. We get 1, 0, 1, 0. And we add 1. What do we get? 1, 0, 1, 1. Which is indeed -5. Isn't this magic? Now, if you look very carefully, if you look at the 4-bit signed integer numbers, the range is from -8 to 7. So this means that for every number there is a negative except -8, this guy. So for -7 we have +7, for -6 we have 6, but for -8 we do not have 8. So 4-bit signed integer cannot represent 8, cannot store the value of 8. So what will happen if you try to find negative of -8, right? So let's try to do this. Yeah, let's try to do this now. So okay, so we take this number -8, or its binary representation 1, 0, 0, 0. The first step is we flip all the bits. We get 0, 1, 1, 1. Then we add 1 to this number. So when we add 1, what really happens is that 1 plus 1 is 1, 0. We get a 0. 1 gets carried over. And again it makes it 0. Again gets carried over, makes it 0. And finally that 1 settles down here. And it gives us a number 1, 0, 0, 0, which is again same as -8. So this is weird. It says that the negative of -8 is -8. So this is the magic. This is why the program was unable to find the negative of the number that I gave you, because the number that I input was actually -231, which is the minimum number that can be represented in a 32-bit signed integer. As you have seen, for 4-bit system, that number is -2 to the power 3 or -8. The same number for 32-bit system becomes this guy. And this number has a special name. It's called int min. And when you try to find the negative of int min, what really happens is it creates an overflow situation. There is no corresponding positive number of int min. And that's why my program was unable to find that.